Hello students, welcome back to Future Foundation. Students, in today's class of circle, we will see the diametric form of a circle. So let's start the class. So make heading first, diametric form of a circle. In this we will write let A x1 y1 and B x2 y2 be two end points of the diameter of a circle, then its equation is given by x minus x1 into x minus x2 plus y minus y1 into y minus y2 is equal to 0. Now let us see its proof. Proof is very simple. Let's say this is a circle and this is a diameter having A and B at its end points x1 y1 and x2 y2 be the coordinates, and let P be any moving point on this circle having coordinates x comma y. Let P x comma y be any moving point. Then by geometry, that is AP and PP are perpendicular. So we can say slope of AP into slope of BP is equal to -1, as AP and BP are perpendicular. So from here y minus y1 upon x minus x1 into y minus y2 upon x minus x2 is equal to -1, or y minus y1 into y minus y2 is equal to minus of x minus x1 into x minus x2, right? Or x minus x1 into x minus x2 plus y minus y1 into y minus y2 is equal to 0, right? This is the diametric form of a circle, right? Now also if I further expand this equation, then it will become x square minus x1 plus x2 times x plus x1 x2 plus y square minus y1 plus y2 times y plus y1 y2 is equal to 0. Now the expression of this equation on LHS contains two quadratic, one in x and one in y, whose roots are the x and y coordinates of ends of the given diameter, right? So from here we can make one note, and note is if we have two equations, one is quadratic in x and other is quadratic in y, then by adding the expressions corresponding to the given equations will give the equation for circle whose diameter will have the coordinates of ends as the roots of the corresponding equation, right? What I'm saying in this note, if suppose if we have two equations, one is quadratic in x and one is quadratic in y, then by joining the expression of two given equations, we will have the equation of circle, and the diameter of that circle will have the ends as the root of the two given quadratic equations, right? For example, suppose what I'm saying in this note, let us take an example. For example, let's say there are two quadratic equations. One is x square minus 3x plus 2 is equal to 0, and other is y square minus 5y plus 6 is equal to 0, right? Then if I add these two, that is x square plus y square minus 3x plus minus 5y plus 8 is equal to 0. Now this is a circle having diameter. If I solve this quadratic, then I will get x is equal to 1 comma 2, and if I solve this quadratic, I will get y is equal to 2 comma 3. So this diameter will have its end points as 1 comma 2 and 2 comma 3, right? And if we want to verify that this is correct or not, then we can check by using the center. So if end points are these, then center would be 3 by 2 comma 5 by 2, and from this circle we can get center as 3 by 2 comma 5 by 2, right? Okay, so this is the note. Now let us do some questions. Question is, ABCD is a square whose side is A. Taking AB and AD as axis, prove that the equation to the circle circumscribing the square is x square plus y square is equal to E times x plus y, right? We need to prove this thing. Now, what is given in the question? That ABCD is a square. Okay. Now it is given that each side is A, right? And it is given that AB and ED are acting as axes. So AB can be taken as x-axis and ED can be taken as y-axis. Now, as it is B on x-axis, so coordinates of B will be E comma 0. Similarly, coordinates of D will be 0 comma A, and A is 0 comma 0. Okay, as we know that AB and AD are perpendicular, so line joining P and D will be the diameter of the circle circumscribing this square. Okay, because AB and ED are perpendicular. So from figure we can see BD is a diameter. So equation of circle circumscribing ABCD is x minus a into x minus 0 plus y minus 0 into y minus a is equal to 0, or x square minus ax plus y square minus ay is equal to 0, or x square plus y square is equal to a times x plus y, which is required proof. Okay, now come to the next question. If y is equal to mx be the equation of a chord of a circle whose radius is a, the origin of coordinates being one extremity of the chord and the axis of x being a diameter of the circle, and prove that the equation of a circle of which this chord is the diameter is 1 plus m square times x square plus y square minus 2e times x plus my is equal to 0. Now students, we have feel that the equation we have to prove can be found by using diametric form, right? So how can we do this? Let us understand this thing first of all by drawing the figure. What is given in this statement? Let us draw in the figure. Y is equal to mx be the chord of a circle, and circle is having center at x-axis. So if I draw this thing like this or like this, right? So how can we decide that which circle is correct? It is decided by the chord. Okay, as chord is having one end on the origin. If this is the chord, y is equal to mx, and this has one end on this origin, so the choice we have is only that we can draw like this, where O and A is the chord. Here it is center and radius is given A, so coordinates of center will be A comma 0. So end of diameter will become 2A comma 0, right? Now we have to draw a circle having this OA as diameter, right? So we have to find equation for yellow circle. So first of all, find equation for green circle using diametric form. So it will be x minus 0 into x minus 2a plus y minus 0 into y minus 0 is equal to 0. So this will be x square minus 2ax plus y square is equal to 0, or x square plus y square minus 2ax is equal to 0. This is the equation for green circle, right? Now if we have the coordinates for a, then we can directly use the diametric form, right? Should we solve the line and circle to get a? So no need to use this method, because we know very well if we have two expressions, one in x and one in y, both are quadratic expression, then if we add these two expressions, then equation will be circle. Equation will be of this circle, right? Now we are going to make quadratic equations in x and y, right? For this I will use 1 and 2 by using 1 and 2, right? For this, if I place mx in place of y in 1, it will be x square plus m square x square minus 2ax is equal to 0, or it will become x square times 1 plus m square minus 2ax is equal to 0, right? This is one equation. And also if I place y by m in place of x in 1, then it would be y square by m square plus y square minus 2a y by m is equal to 0, or y square plus m square y square minus 2a is equal to 0, or y square times 1 plus m square minus 2EMY is equal to 0. This is other quadratic equation in y. Now, therefore, required equation would be x square plus y square times 1 plus m square. So 1 plus m square times x square plus y square minus 2e times x plus my is equal to 0. Okay, by adding 3 and 4. Okay, this was done by adding 3 and 4. Okay, let us take one more question. The point of intersection of this line 4x minus 3y minus 10 is equal to 0 and this circle x square plus y square minus 2x plus 4y minus 20 is equal to 0. Okay, so is equal to question mark. So we have to find the point of intersection for this line and circle, right? So as we are talking for diametric form, then we have feel that is this line is along the diameter of this circle or not. So let us check. So x square plus y square minus 2x plus 4y minus 20 is equal to 0 is having center as 1 comma minus 2, right, minus g comma minus f, and the radius is root over 1 square plus 2 square, that is 4, minus minus plus 20, which is 5. So radius is 5. And if I put this coordinates of center in this line, so is it satisfied? Let us check. 4 into 1 minus 3 into minus 2 minus 10 is equal to 0. So here 0 is equal to 0. Yeah. So it means 4x minus 3y minus 10 is equal to 0 is a diameter. It's a diameter. It means this is a circle. This point is center, which is 1 comma minus 2, right? And this is origin. So this line is having slope positive, so it will go through like this diameter. 4x minus 3y minus 10 is equal to 0. Okay, now radius is 5, so I have to find p and q. So if I use parametric form, then I can find p and q. For this we have to find cos theta and sin theta. So tan theta is slope of the line, which is 4 by 3. Cos theta is 3 by 5. Sin theta is 4 by 5. So for having P and Q, x is equal to plus minus r cos theta plus x1 and y is equal to plus minus r sin theta plus y1, right? From here I can get x and y. X is equal to plus minus r is 5, cos theta is 3 by 5 plus x1 is 1 and y is plus minus 5, 4 into 4 by 5 plus y1 is minus 2, right? So I can say q is for plus sign and v for minus sign. So q is plus 3 plus 1, 4 comma plus 4 minus 2, 2, and v would be minus 3 plus 1 minus 2 and minus 4 minus 2 minus, right? So these are the points, minus 2 comma minus 6 in third quadrant and 4 comma 2 in first quadrant, right? So students, for this class we are done. Let's meet in next class. Till then, bye bye. Take care.